Hi everyone, sorry for having to do a part 2 of this video. My battery ran out and now I'm having to lay on the floor to finish this video. We're going to do some unitary method stuff now. We've got a problem here about running. If it says if I can run 5 kilometers in 20 minutes, assume I can maintain the same pace, how far can I run in 40 minutes? So standard procedure, write the ratio, 5 kilometers in 20 minutes. And we're trying to work out how long it would take to do how far you could run in 40 minutes. I'm sure you remember this. We're looking at what did you multiply 20 by to make 40, and you multiplied it by 2. So over on the other side, we do exactly the same thing. We multiply the distance by 2 as well. And that means that in theory, no chance of me actually doing it, I could run a 10 kilometer in 40 minutes. So that's quite straightforward. That's direct. What about if I can run 5 kilometers in 20 minutes, so I'll write that ratio straight away. Assuming that I can run the same pace, how far can I run in 16 minutes? So here it's not a straightforward going straight to 16, that wouldn't work. So instead what you're going to have to do is work out a step in between before you get to 16 minutes. Most logical thing here is to think, well, what is a factor of 20 and of 16? And if you're racking your brains, you're probably thinking 4. So let's go to 4 minutes first. And to do this, we'd have to divide our answer by 5. And then the second step, to go from 4 to 16, we'd multiply it by 4. And we have to do exactly the same thing on the other side of our ratio. So the first thing we're going to do, instead of 5 kilometers, we're going to divide it by 5 kilometers. So we would do 1 kilometer in 4 minutes. Rapid pace. And then the next bit we're going to have to do, so after we divided by 5, we're going to be timesing by 4, and that means that 4 kilometers could be completed in 16 minutes. Remember, whatever you do to one side, you must do to the other. These are directly proportional. There is another one called inversely proportional, and we'll look at those later. Okay, for school lunches, Jan provides 15 bread rolls for every 45 children. How many bread rolls are needed for 150 children? I would like you to write the ratio, do it on your own, and we'll talk about it in a second. Okay, so the ratio you should have written, we've got 15 bread rolls. Okay, 15, I'm going to put rolls for every 45 children. And we need 150 children. We can't easily go straight from 45 to 150. You might be able to, but probably you won't. So what we're going to do is think we need to get to 150. What common factor do we know? What number goes into both of those? There could be a few steps here. You could go down to 5 children if you wanted to, or you could go down to 15 children and times it by 10, but let's just go to 5. So if we go to 5 children, that'll be dividing by 9. Goodness, that's a bit difficult. Let's look at an easier option. What about if we go to 15 children? This means dividing by 3. Much nicer. And then from there, we're going to times it by 10. So let's go 15 divided by 3. Gives us 5 rolls. So there are 5 rolls for every 15 children. And we're going to times that by 10, just like we did on the other side. And that will give us 10 times 5, 50 rolls for 150 children. Okay, have a go at this. If you want to get on now with the task, if you have any questions, pop into the live sessions. Good luck.